Okay. And then I can come back and oh, right. I know what I have to do. I have to go here and do this. I know how to use computers. I honestly do.
Okay, audio works.
Okay. All right, I'm ready to start. Well, I can probably just run things right from here, and there's nobody really extra. Everyone can see me, right? Hear me what I'm doing. Okay, and the people remotely can hear, I assume.
Let me double check. We
Have a chat thing.
a chat. Let me bring that up.
So can I put in a special request?
Sure.
So I need to know how to transfer files onto my work directory in Maverick.
Okay. From where? From your laptop?
SCP. How do I do the SCP thing?
Okay.
Yeah.
All right. Sure.
Okay.
Okay.
So I've been working on Maverick. Okay.
Okay.
And I
Just announce or introduce
right
yourself.
there.
Okay. Hello out there. My name is Dave Semeraro, and we're going to start our session on remote and collaborative visualization. So I'm going to tell you a little bit about how to access the visualization capabilities that we provide here at TACC remotely. Okay, so what that means is, of course, you're not going to physically have to come to Texas and go into our machine room and access things directly like you would your laptop, for example. But instead, you would access these resources from home or from wherever you happen to be. We're all used to accessing things remotely. We all do remote banking and those sorts of things where you're accessing remote servers that are not local to your personal hardware. There are a few wrinkles that are involved when you're accessing remote systems that provide graphics. And we're going to talk a little bit about what those particulars are so that you can get high performance graphics delivered to your workstation or laptop or whatever you happen to be using our resources. So you see before you, these are two of the resources that we provide, two of several resources that we provide here at TACC for people to use. The first one is our first system is called Maverick, and it's a HP cluster with NVIDIA graphics on each node. There are 132 nodes with 256 gigabytes of RAM per node, and that's a relatively large amount for HPC systems to have. Each node has 20 cores, so there's really two levels of parallelism involved. You have the 132 nodes that are connected by a network, high-speed communication network, and then on each node there are 20 cores that you can run in a multi-threaded sort of fashion. Each node has an NVIDIA K40 GPU. These are still fairly capable GPUs with 12 gigabytes of graphics memory each, and that's a fair amount of graphics RAM. So that's in addition to the 256 gig of system RAM. Okay. So the trick with remote visualization is really getting access to that graphics hardware remotely. So graphics hardware isn't really built with necessarily with that in mind, but we've got some facilities that let us do access that remote facility. Okay, so our big machine is Stampede, and that's where most people do their computation, right, on Stampede. So you'll be running your simulations or doing analysis on your large data on our big system. And we've provided 128 of the nodes of the Stampede nodes are visualization nodes. So what that means is that of the, I can't remember how many nodes Stampede has. You know, Ann? The total number of Stampede nodes, 640 some 6,400 nodes. We have 128 visualization nodes. The thing to note here is that these visualization nodes are connected directly into the communication network of Stampede itself, rather than being connected via a shared file system or what have you. And speaking of shared file systems, both of these machines share the Stockyard parallel file system. So you can generate data on Stampede and save it to a directory on the Stockyard file system and access that data directly from Maverick. The file systems are present on both systems, on both machines. So these are the primary resources we're going to talk about accessing today. So here's a little just a description of what we mean when we're talking about remote visualization. Okay, you'll have at the remote site, you have the HPC systems, which are Stampede and Maverick for the most part. You'll have possibly a large-scale visualization resource, which would be Maverick in our case, and connected to also a large data archive, which we provide. The connection to your local site, you want to display graphics on your local site, and you're connected to these systems via the wide area network. And you're primarily going to be moving pixel data, which is image data, and mouse movements, so that you can move your, interact with your visualizations via the mouse. So I'm going to talk about two methods of remote access. The first one you're probably all familiar with because you have logged into remote machines before, and that's access via direct connection with secure shell or SSH. And this gives you your basic command line interface, which is useful for moving data, managing files, submitting jobs, and the like. Another access method is through the TACC Visualization Portal. And so it is it's a simplified web-based access method for interacting with remote Viz sessions through VNC. And I will, so that provides you, the VNC thing is what we're particularly interested in by using the TACC Visualization Portal. It sort of simplifies setting up the VNC session. And what VNC does is it's like a shared desktop or a remote desktop system. So you get a window with VNC that basically looks like a desktop that you would get on if you were directly logged in to the remote system. Finally, I'll tell you a little bit about how to set up the VNC connection directly without going through the portal. That's fairly handy for when you don't have, when you don't want to deal with what the portal provides, and you want to do something a little bit more sophisticated, perhaps. So to log in to the systems using SSH, if you're on a Mac or a Linux machine, you start with a terminal window, which gives you a command line interface on your local system, and you use the SSH command from the command line. So in that case, you would type SSH space and the domain name, the full qualified domain name of the system you're logging onto. So for example, you would type SSH followed by maverick.tac.utexas.edu, and then the SSH program would fire up and it would connect you to the remote system. It would ask you for your password, which you would type in, and then you have essentially a remote shell on that computer, and you can type in ls to display your directory structure and manipulate files and launch applications and do whatever you would need. For Windows, it's slightly different. For Windows, you have to have an SSH client. I like using Putty. Some people have, there are a variety of SSH clients for Windows. So basically with Putty is a graphical user interface based system client for SSH. And this is what the user interface looks like for Putty. So for Putty, you need to type in the host name of the system that you want to log into, maverick.tac.utexas.edu or stampede.tac.utexas.edu, and then you click the open button, and that does basically the same thing as your SSH from the command line on Mac. So what you see when it tries to connect is it will show you a shell window that looks like this on your Windows box, and it'll ask you for your login name, and you will type in whatever your user account is on that, and then it'll ask you for a password. It won't pop up a separate window. It'll just ask you in the same window for your password. And once you type that in, you'll get the message of the day, and you'll have your Unix command line, just like if you were logging from a Linux or a Mac. And from here, of course, you can do all the wonderful things that you need to do. But that doesn't really help you terribly much with the visualization part. So now we've seen how we can connect to the remote system, and now we're going to figure out how we can do some visualization. So the easiest access to visualization is through a TACC Visualization Portal, and what that does is there's the URL there for the TACC Vis Portal. You can navigate to that if you want and have a look. You have to have a portal login in order to actually access the functionality of the portal. But that's not hard to get if you've got a TACC account. I think it's relatively easy to request access to the Vis Portal. So what is the Visualization Portal? It's basically a web interface that lets you do a lot of different things through a web session rather than through command line via SSH, right? So it avoids sort of the complexity of manually managing your jobs. And for many users, it can be the primary method for interacting with Maverick. I use this portal almost every day for setting up visualization connections to Maverick. It's just a couple of clicks, and it provides you with all the options in a graphical manner. And it's just a real simple way of getting a interactive visualization session on either Stampede or Maverick. So what you're looking at here is what the Vis Portal looks like. So if you navigated to the Vis Portal, you would see this page. And so you would have to, you can log in on the upper right. There's a login box. You can sign in with either using your TACC account or an Exceed portal account, username and password. And the four little windows on the bottom describe some of the things that you can do. You can do You can look at the job status for all jobs on the system. You can look at, you can set up a VNC or a virtual desktop. But you can also, two other bits of functionality on the Viz portal are the ability to run Python notebooks, and also the ability to do remote statistical analysis using R. So we also provide a connection for R Studio. So if you're doing statistical work or you need to use R, using the R Studio facility is pretty handy. So all four of those things are provided through the visualization portal. So once you've logged in, I'm going to show you how to set up your VNC session or how to start a job on the system. So you have, this is an older slide. I think you also have the ability to if you look at the top, you see two buttons, one for Maverick and one for Stampede. So you can set up a remote session on either Maverick or Stampede. And I believe you can do one on Wrangler now too, if I'm not mistaken. You need to set a project, which is the account name that you want to charge your session to. If you have more than one account, you need to choose. If you only have one, there'll only be, of course, one possibility in that project selection. Then you want to figure out what type of interactive session you want. We're gonna look at using VNC because we're gonna do graphics. But this is where you can also select your IPython or Python notebook session, or you can start up our studio session, whichever you like. You need to select your desktop resolution. So that's the resolution of the remote desktop that you're going to get. So if you need a lot of pixels, this is where you select that setting. You're also allowed to choose the number of nodes. So you can set up this session to use some of the parallel graphics tools that we have. And in order to really take advantage of parallelism, you have to start a job that has enough nodes, more than one node, for example. If one node is not parallel, two or more are the sort of the minimum, right? You can do multi-threaded on a single node, but the tools that we support for visualization use MPI rather than multi-threaded multi-threading for parallelism. Anyway, for the most part, so choosing a number of nodes greater than one is a good thing. Then you can choose the number of processes per node. So on Maverick, you have 20 cores, so you can select up to 20 processes on the system to be allocated. Then you click you click the start job, and what happens is the web server collects all the settings that you have given it, and it submits a job to the job queue on the remote system for you. So you don't have to set up a job script yourself. It will go ahead and do that for you. So when you click submit the request, you'll see a status window pop up that tells you that it's checked all the requirements that you need to have have satisfied to submit your job, and that your job is queued. Now, if the queue is full, if there are a lot of people using the resource, you may wait a while before you actually get your resource allocated. Usually, if you request a small number of nodes for a relatively short amount of time, there'll be enough resource available, and your resource will be granted almost instantaneously. But there are days when the queue is full and a lot of people are doing analysis that you may have to wait 20 minutes or so before you get your allocation. Once you get your allocation, this is what you see. And this is what it looks like when you're using Chrome. You have a desktop, and you'll see that in the top left corner of the desktop, it's going to ask you for a password. So this is a VNC desktop, and you need to type in what's called your VNC password. If you don't have a VNC password set up, you need to have a VNC password set up before you're able to access the desktop. There are two ways to do this. One is to use SSH to log into the remote system and get a command line to use, and then you'll issue the VNC password command, and it'll prompt you for a password to use for VNC. Or if you don't have one and you're trying to use the visualization portal, it'll prompt you for one before it submits the job. So then once you type in your password, you have a desktop basically with shell windows, and you can see their icons on this particular desktop because I had images saved to the desktop. And you can use these shells to start the visualization applications themselves.
I have a question.
Sure.
What's the command to get a second window up within the?
Oh, okay. Within the VNC, let me point to it with my. So if you see here, here's a shell window. Here's another shell window. If you go up here to applications menu, and you click on that, that's a pull down menu, and inside there'll be a button called Terminal Emulator. And if you click on Terminal Emulator, it'll pop up one of these windows.
Is there, so if I'm already on, I just go straight to pair view. If I'm on pair view, do I go back?
What do you mean?
Well, I don't have a applications menu on. If I've got the pair view workstation up.
Oh, okay. So the question is, if you're already using, are you using ParaView in the remote
Yeah,
desktop?
if you're not there yet, that's fine.
Okay.
I can't.
I'm getting to that part.
Okay.
Point.
That makes
Okay. I'll get to that point. So anyway, yes, and inside this application menu, there's a file manager, and there's a few other standard Linux desktop applications that you can use. Okay, so this button here, if you click that gives you a dialog that lets you terminate your VNC session if you so choose. So up here you'll see, this. You'll get a tab up on the command line or up on the control bar here for each shell window that you have. So this and they'll be so this window is active. So you'll see that this is sort of highlighted or sunken here. So that indicates that this particular window is active. So if I want to activate a different window, I can either just click on the window itself, or I can click on one of these tabs up on the top here. So anything you can do on a regular Linux desktop, you can now do here. So which includes starting visualization applications like Visit and ParaView. Okay. Yeah.
If you you can hit that little hide in the bottom right, and that'll remove that little that one right there, and that'll just remove that little bit.
Oh, that little strip there. Okay. All right. There we go. Okay. So that's how you get a VNC session through the portal. There's another way to start the VNC session if you don't want to log into the portal for some reason. But starting a VNC session with the portal sort of automatically gives you a VNC client. So there's two ends to the VNC picture. There's a VNC server, which runs on the remote system, and then there's a client that runs on your local system that lets you display display that desktop locally, right? So if you want to start a VNC session without going through the portal, you need to first log in with a shell, right? So you do your SSH session, and from a shell, and from the command line, then you're going to want to submit your own VNC server job request. Okay, so TACC has provided a batch script called job.vnc on all our systems, and it's all located in the directory share.slurm job.vnc. And this script is set up to automatically start VNC sessions for you. You don't have to write it, you can just use it. So in order to use it, you use the sbatch command. Sbatch is the Slurm command for submitting jobs. When you do that, you have the option of setting options. So the options that, for example, one of the options might be which account you want to use. So any sbatch options go before the job.vnc command. So some options might be the project number, which specifies the project that you've got, or the number of the amount of time you want to have reserved, or the number of nodes that you want in the session. So once you do that, once you submit your job, once it starts, it'll create a file called vncserver.out. And when you look at that file, I've done a tail on that file here, and you can see it'll give you an address to connect to. Now, it'll instruct you to set up a tunnel, but I'm just going to tell you how to connect without having to use the tunnel. The tunnel, what the SSH tunnel does for you is it encrypts the communications so that so no one can snoop on your VNC session, right? But the key part that we're looking for here is the machine name and port number that VNC is listening on. So if you look at the bottom, it says to connect to VNC client, it says SSH tunnel port 12511 to maverick.tac.utexas.edu 12511. So that machine name and port number, maverick.tac.utexas.edu, and port 12511 is the port that Maverick is listening on for your VNC connection. You can also use the VNC session. You can also set up your VNC session through the portal and get the machine name and port number from the Jobs tab. So if you look at this page, when you start the visualization session, when your job runs, before we landed up, it starts this desktop tab, and you end up with this VNC desktop right here. Well, if you click on the Jobs tab, you can see now that you're running a job on Maverick, and here's the machine name, viz.tac.utexas.edu, and here's the port number that you want to connect to. So instead of using, you have the option of using a different client other than the portal client. If you want to connect to VNC, you don't have to use this desktop. If people find it a little restrictive, you can use your own client. And this is the machine name and the port number to connect with that client. So my particular client on my Windows box is Tiger VNC. There's a variety of open source, open software out there to do this. Type VNC, Chicken of the VNC is another one. There are a variety of clients available. This is what it looks like when I connect with the remote with my particular Type VNC session. So I've copied the server address, and I'll start up the Type VNC, and this dialog pops up and asks me where the VNC server is. So I type in the machine name and the port number, and then I click connect, and then it'll ask me to authenticate with my VNC password that we had previously set up. And this is what my VNC session looks like. So if you'll notice, it's very similar to the desktop that I had. In fact, it's identical to the desktop that I had through the portal, through the web interface. But now what I'm seeing is the desktop presented to me via my own local VNC client. And you interact with this desktop just the same way you did before with the portal-based, the web-based access. It's virtually the same. Okay, so now we're connected, right? We are connected. So now what do we do? That was a lot of work just to get connected, right? So, but once you've done that, this is a note on parallel visualization that I went over before. You're going to want to select something. If you're going to use one of the parallel visualization tools like ParaView or Visit that we support, you're going to have to select. You're going to have to set up your VNC session with more than one node. If you only want to run these applications in serial, which is perfectly legal and useful in many senses, you don't have to get a larger allocation. You don't need more than one node. Okay, we've got a desktop. We've got a session going. Okay, so TACC uses the module session or module system to manage your environment, to set paths and library paths and other environment variables. Rather than having to set those manually, you can set them by using the module command. So in order to, for example, run ParaView, you would need to load the ParaView module, okay? And the same with Visit, okay? So in order to do that, in order to see the different software packages that are available for loading, you type module avail, and it will give you a list in the command line in your shell window. It'll give you a list of all the modules that are available for you to use, right? So, for example, maybe we want to run ParaView, and in that case, we do module load and type Python and ParaView. I like to use the Python interface for ParaView, so I'll load the Python module in addition to the ParaView module. Now, here's a key thing to note. So what VNC does is it forwards your X Windows desktop to your local desktop, and it does what's called oops. I lost my slide. There we go. Sorry, I did something wrong. It does screen scraping to do that, so it collects the pixels and ships them. Unfortunately, the screen scraping doesn't work on OpenGL applications. You have to do something extra to do that. So in order to get OpenGL graphics to work, which is everything that's in this window under Visit, you need to run the application in a framework called Virtual GL. So you need to start any app that uses OpenGL. You prepend the word VGL run in front of that application, and then that lets you forward your OpenGL graphics through the VNC session. So once you start your session, now it's running on your desktop. You can interact with the graphics that you've generated. This is just an example from a data set that I had. This is running Visit, so all the Visit visualization. Sorry, I keep doing that. All right. I'm using a touchpad, and I loathe touchpads because if I breathe on it, it freaks out. So, where am I? Show. There. Okay, now I'm just not going to touch it. So what you're looking at here is the Visit graphical user interface. I've already loaded a data set, and I've selected the isosurface functionality from Visit, and selected an isosurface level. And it's so what's happened here is that this application is running on Maverick, so it's accessing the data on your TACC data, and it's running using the graphics hardware on Maverick. So you have all the high-speed graphics capability built into Maverick's nodes at your disposal. So that is basically how you access visualization applications through the remote capabilities that we provide here at TACC. Are there any questions? Anybody have any questions about how to do any of this stuff? No.
Do you want to take a quick break?
Finish up a little early.
Everybody has everybody has accounts too, right?
The locals, yeah, we
Okay.
got you guys set up on an application. So
Did you already hand out I was gonna say we could take a break, but if you wanted to try logging in, and then I can just help whoever is having problems.
Yeah. Yeah, if you guys want to try that. Yeah.
I'm using the chicken to log into that, but I don't have the application part.
we don't have Viz portal or.
Oh, you don't have the. Let me go back here.
You don't have the what?
Application
Oh, I think
menu.
it's just, you just need to minimize the stuff, the pair view. Oh, it's your window manager. I think they're using TWM.
Oh, okay.
So I can show you, so.
For that, I think you right click anywhere on the desktop, and that should give you a list of. You can
Yeah.
see Xterm would give you a
Open
show.
terminal here.
Yeah, there
that'll do that. And also, if you do have a minimal window manager, you can always type in extern ampersand, that'll open one. You somehow can't access from mouse.
I sent you.
Yeah, it's because the particular window manager doesn't have a menu bar.
So you should be able to right now.
Because I just minimized it, so now I can open my.
Oh, yeah. I bet that, I'll help you get a better window manager. That's
So,
the-
yeah. Is the window manager mentioned in the Maverick user guide?
Yeah, I think it is, actually. I think they give you, what you need to copy and paste. into your
Yeah, put your X startup. Yeah, so there should be a file in your home directory on Maverick that's called, I think it's .bnc, so you can't, it's a hidden file. So, but if you get into that directory .bnc, there'll be a file called X startup, I think. And inside that, it'll list your window manager and some other things.
Yeah, let me find the reference.
Now his.
Right, so
And then
if you go to the Maverick users guide on the TACC webpage, there's detailed instructions on how to do all of this stuff, how to set up your window manager, how to do various things.
Sorry, where those questions?
It's in the Maverick user guide.
Maverick user guide.
So, yeah, maybe it's easiest for everyone just to bring it up because then again, it tells you what you need to copy and paste to get a better window manager. But I think that's better.
Let me see if I can.
Trying to tell you, since if you just copy and paste the line.
Okay.
It looks like he's wondering, I'm not sure.
Yeah, that's good.
Welcome to employees.
Oh, it should, welcome to the first start of the panel. Choose to set up. Yeah, looks like it's kind of locked up a little bit. Yeah. Yeah.
Okay, one thing I should mention is that for some reason if you're using the Viz portal, the desktop that you get, the VNC desktop that you get using Chrome, for some reason doesn't behave very well. You'll get a desktop, but it won't let you move windows around. So you're better off using Firefox. Firefox works fairly well.
I'm using Chrome, I'm refreshing.
Yeah, I would
You're
recommend
using
using
Chrome
the
and it's
external
letting you-
VNC.
Okay, well, you're
Because
using
it works.
Chicken of the Sea,
I
right?
mean, that's always good
Yeah,
for
I was
emergencies,
initially-
but I think if you're doing any work compared, you get,
Oh,
gonna get annoying.
And Chrome works well, maybe it's the
So are you suggesting not to use the TACC portal?
And
But
it,
you
oh
can
yeah,
use
it works
TACC
fine
portal,
for you, right?
but-
Oh, okay, good.
I would launch
Chrome for me
the job in the
doesn't
TACC
seem to
portal,
work
but then
very well.
actually use
Yeah,
the
Windows
application,
Windows
like
Windows
the VNC,
Windows
whatever window you
might work
or
better.
VNC or
I'm not sure.
whatever.
I'm not
Something,
sure. So you want the server name
So,
or?
So,
Just
okay,
one.
so let me back, I'm sorry. I
Yeah.
didn't-
Her expertise on this.
So,
What's his? That was a question about the server name?
so
Let me see
you're
if I can-
saying,
I don't.
so I don't.
Yeah,
Yeah.
so I should open a separate,
Yeah, there's, VNC, their
Yes.
VNC client applications you can use.
yes, I've
So
done
instead
that.
of opening it in the browser, you open it in the application,
So,
and then it tends to be
should I,
like
should I
the,
close this down?
yeah, let me just show you, do you have yours still up?
Okay, VNC.
Oh, you're running in the portal.
I have both.
Okay, so show her, just to show her what it looks like.
Oh,
So
server
it
name,
looks
that
the
would be.
But if you're doing a lot of
Maverick,
stuff in your
yeah,
view, it's just a little more stable, and you can see some look like that, so it's in its own separate window.
Okay,
So,
did you start the
so I know,
server
I've always been told, yeah,
on
to start it in a separate window.
Mm-hmm.
So it's in a separate window in the same
Start
area.
the server, okay.
It's,
Disconnect
well,
the
it's
browser.
not,
No,
I mean, do I need to open another browser?
it's not gonna be in a browser, it's gonna be in
Connected on
a
the
VNC
browser.
application. Let's go ahead and get you one.
So
Maybe you already
VNC
have one.
I do,
allow-
actually, I do.
unless you set up sharing
Yeah.
exclusively, VNC
And
won't
so
allow one.
You're just gonna
connected.
use,
Oh, okay,
So if you're connected, it's not gonna let you.
you know, you
connect
use
again.
this,
disconnect.
copy
Yeah,
it,
you can disconnect.
And then
Is that my number or is that my session number?
We're gonna do.
that's
the
your session number.
Oh,
Yeah, every
okay.
time you,
Okay.
you're gonna get a unique session number.
Or is that,
Oh, I see.
is that,
Yeah, and then
when do you wanna start?
like that is when now it's gonna be the same, exactly the same thing.
Well,
but
the
it's
remote
a little more stable
with
and it's
NVIDIA,
less annoying.
I don't know
Doing
who's
a lot of
doing
stuff.
Yeah.
And browser gets a
I don't know
little.
what's next, the visit or
Yeah.
So you got that up by just
somebody else will
typing
be
in.
doing.
Yeah, just copy and pasting where your session is
Okay,
at.
so this is.
So you can, you know, that session is gonna be the same, if you move to a different computer, if you decide to go home and start it up later,
Mhm.
you just copy and paste that again, and for the duration of the session, it'll be there. So it's kind of nice, sometimes if I start something at home, I have to work, and I have to go home, and I can just
So,
start back up again.
yes. I don't,
Yeah, yeah,
It's
that's very nice.
intense, but I missed one step. Like, I see session
Oh,
available,
is that
but
user? Oh, user
what
ID,
did you
okay,
click to
that's-
get the
okay.
VNC window to begin?
It's your app. It's one of the
Oh.
applications.
Yeah, I just searched, I use the, Apple space to search, and then I just typed in VNC.
Oh, right.
Okay, in case you had it installed. so I didn't have to
Okay,
download it.
Or if it's a VNC.
Oh, it's just named chicken? I like how you say when I have the chicken instead of like my VNC session, you just call it the chicken.
Yeah.
Is anyone else having any problems with, getting their VNC session?
So I've got
You could go ahead and
And share. And then just go ahead and bring up your slides.
Okay. All right. Sorry about the delay. I was helping some of the local people get connected. So on the agenda for today was supposed to be visit, but as you recall, yesterday we didn't quite finish the peer review. So I think what I'll do is finish peer review first, and then we can get to visit later after lunch, just because they are pretty similar. And I feel like the scripting and peer review and animation panel is more useful rather than starting at visit. Let me close this door.
So should we log out of our Maverick sessions?
It's up to you. You know, you could use peer review in Maverick for the local people that are connected, but it's probably going to be less painful. I don't want to call it painful, but it'll probably be easier to just do it locally. And then we can deal, especially for you, because we are still using that other window manager that's kind of old. So if you minimize anything, it's not going to go to the menu bar. And so after I get you set up in the afternoon, we can go back to that. Okay, so let me go back to where we left off. Does anybody remotely have any questions about VNC or the last session? I know you guys all don't necessarily have accounts, but some of you might already be TACC resource users. Are there any questions on that end? Oh, okay. Just chime in if you have any questions. And I'll go back to where we were yesterday. Okay. So today I wanted to show you a little bit about how to get started with scripting in PeerView to create a simple animation. And I also wanted to show you a brief introduction to the animation panel. So we're going to do a very similar animation first in the animation panel and then via scripting. So since we only have one screen in this room, it's going to work a little differently. I'm going to just go between the slides and the application. For people here, you know, yesterday we had the slides up on one, and then I was doing the demo. But since we only have one, are you confused
Do I need
about
to
something?
download that file?
Did I send you a?
There's no new file actually.
Well, I
slide
had to
from
step out
yesterday.
yesterday, and I'm just the problem person.
No, that's okay. You should have it in your email, the slide from the peer review demo.
Yeah, I'm just finishing up what we did yesterday.
I know, but I didn't put it up, so I just want to be.
Oh, okay, sure. I think for people that are in this room, you probably don't need to reference the slides because I'll already be doing that and talking to you since I only have one screen this time. And then feel free to stop me. The hands-on portion designed to stop as often as necessary to give people individual help. So if you run into any problems, it's fine to just stop me. Okay. So I'm going to open up PeerView. Put my resolutions. Close my mail. Let me just start it over again. I'm going to open up PeerView. So yesterday, shortly before we stopped, I had everybody save a state. So if you go ahead and just open that state again, load state, and then navigate to wherever you saved your state from yesterday. Disk is what I called mine. So you should see wherever you left off yesterday. If anyone does anyone not have their state saved from yesterday? I can go over really quickly, just do it. I mean, the only purpose of this now is just to show you how to use the animation panel. So I can quickly go over how to recreate something very simple. Looks like some people might not have their state saved. So if we go back and then just open up the disk out ref.ex2 that we downloaded yesterday, hit apply, and then I'm just going to add one contour. I'll color by, oops, one moment. So remember, load all the variables in, and then contour by temperature. Oops. So if you guys that are here, when I first started to do the contour, I didn't have all the variables selected, so it didn't give me the full list. Remember yesterday I mentioned if you don't select them all, then when you try to do a successive operation, it won't show up. So I went back, selected them all, but because the contour I had already added the contour object, it wasn't aware of those variables, so I deleted the contour and then re-added it. And in theory, all my variables should be there, so I could select. So I'm just redoing the first step of what we did yesterday, so that we can start with the animation panel. But for those of you that have your PVSM from yesterday, it doesn't matter. I just wanted to set something simple up so we could see how to animate it, basically. And then we're gonna do the same thing via the script. So I'm gonna react to the contour and select contour by, yeah, what? Yeah, color by. It should also have a contour by, because that's gonna tell us what isosurface range we're gonna have. So let me try that one more time. Make sure I have all the variables. Yes, contour. Okay, wait, hold on. I'm just gonna, what's that?
Don't need to apply after you click all the variables.
Yeah, I do. Did I forget to do that?
Yeah.
Okay, maybe that's the problem.
So,
Okay, apply. Okay, and then contour. Okay, there, now we're seeing the full list. Yeah, I forgot. Thank you for pointing that out. And then I'm going to contour by temperature and select 400. Okay, hit apply again. Okay, that was strange. Why did it disappear for a second? And then I'm going to color by pressure, let's say. Okay, so this is just the first 3 steps of what we did yesterday, except it took 15 today. So what we want to do is see how you can use the animation panel to do a simple isosurface sweep and a camera rotation. Say if you have created a visualization and you wanted to save out a more complex animation. So if you go to view, animation view, there is an animation panel that will open up. So there's mode sequence, which just means you know, arbitrary 0, 1, 2, how many frames you want, or real time. So if you know you want something that's 10 seconds long, you can use real time. I'm going to use real time today. We'll make a 10-second animation. And then if you notice under this time heading here, there's the time, the general timekeeper, and then there's a place where you can select some options and then add a plus sign. So that's how you're going to add different tracks to your animation. So the first one I want to add is just a camera track. So we're going to rotate around our object. So I'm going to select camera, orbit. Notice there's like a couple different things. Follow paths. You can also load in. Let's say if you wanted to have, you have a trajectory you wanted it to follow, you can have it follow a path or follow the data. But orbit is definitely the simplest. So we'll just do that one.
so if you can just hold on.
Yeah, no problem. And if you want me to back up, I can too.
No, I don't know why I clicked on my animation window. It's a simple thing. Okay, all right, now I've got it. Okay.
You see it? It's down there at the bottom. Okay.
All right. Create work.
Yeah, and then so I just
What do I click?
so if you look right here, there's a little plus sign, and then we have camera.
Okay.
So in this case, you'll see different things depending on if you loaded the state from yesterday. You're going to see every filter that you added to your animation in this list. In this case, I only see the contour the main data set. And then Python, you can also import a Python script to run if you have something more complex that you wanted to do. And then camera, Python, and the data set are always there, followed by a list of all of the filters that you've that you've added to your visualization. Okay, so, and then the next thing I did was just to look at the parameters, make sure they look okay. In this case, we're not going to edit anything because we just want a simple orbit around the center, and peer review by default will correctly assume that you want just a simple rotation, since that's the most common one. And we'll hit OK. And notice after I hit OK, it kind of becomes, when it looks, when it has a little plus in the drop-down menu, that's not part of your timeline yet until you hit OK, and then it adds to your, the track is added. So let's just see what that looks like. So we hit play, it's rotating around. All right. So we're going to see, next we're going to see how to do the same thing with Python, if you wanted to do that with Python instead of through the animation panel. But the other nice thing, if you wanted to do something with your filters, like let's say if you wanted to look at an isosurface sweep where you wanted to go through a lot of, a full range of isosurfaces in the course of an animation, maybe you wanted to do something, or like a cutaway where you have a slicing plane that moves through your data, anything like that, any of the filters that you can add, you can animate in the animation panel. So to do something like a contour sweep, we can select contour. And then it comes up with different options. And I don't really know what the point merge options do. Visibility and opacity, you could also make it appear, or appear or disappears, visibility, opacity. You could do something like make it fade to be transparent over the number of time steps that you desire. Or isosurfaces is gonna give you the option for an isosurface sweep. So I hit the plus sign, and then you notice that it has the a little ramp here with the start point for the isosurface and the end point. And if I double click on it, I can change the parameters, so including the start time and the end time. So if I wanted to build up a complex animation where I have something happening for half the time or quarter of the time here, you would just edit the time, the end point or the start point. And then you can also change the isosurface values, and then the interpolation. So if it's going to, how it's going to play, if it's going to be linear, or if you want to have a different effect, you can pick that. Okay, and then hit OK. And then play, and we can see, so we have both. We have the camera rotation and the isosurface sweep. So it's going through from the 290 contour to the 900 contour. So that's pretty easy, right, to set up anything like that. And it's once you play with it a little, you get a better feel for how you could do something like that. Does anyone have any questions, or do you want a minute to try that? Francesca, do you need?
So is this moving through the data changes as well?
The data changes, like?
Yeah, I guess. So I've just done this before. So
You're sure you want me to come look at? Okay. Yeah, so the one thing that I feel like is kind of not so intuitive is if you want to have things happening in time, you can't, there's no way to, I feel like when you use video editing, you can kind of drag, the span of time that you want in the tracks, and peer review doesn't really let you do that. There's no way, but you can, like I said, double click and then change the end time. So if we do something like 0, 2, and then we just want the halfway point, you can see that now your animation is halfway. And then if we want to do something different, let's say we wanted to do a different contour, we could add that. How come it's not adding right now? Maybe it doesn't like me adding the same thing. Okay, so let's say we wanted to change the opacity at that point, then you would have to double click it and then change the time manually. So 0.5 to 1 and hit OK. And so now you can see we've built up something where we have something happening for half the time and then something else where we change the opacity from 0 to 1. So we hit play.
Possible to run these in slow motion.
Yeah, you can. Well, hold on. Let me change that from 1 to 0. Looks like it didn't have the intended effect. Yeah, if you change the time, so the duration we have here, so if I want it to run really slowly, I could just bump the total. You know, it's going to stretch whatever you set up for the total amount of time you've specified. Or it's supposed to. Clearly that's not happening because it's playing at exactly the same speed. So there, that's what kind of what I was expecting would happen. Yours changed? Yeah, usually it does. I don't know why it's not. I'm pretty sure if you exported it, it would be stretched properly.
Is there any file option that you have to
There's not for the animation panel, but
Did you enter after you typed in the-
oh yeah, that's true. Maybe I didn't press enter. Let's see. And maybe if I change the,
You don't want to come up for me this time.
okay, yeah, there we go. I think for peer view, like the mouse was still in the box, so it hadn't updated yet.
Well, a lot of programs they do that.
Yeah, this is I don't know if any of you people who do have a coding background, this is built on top of Qt. So if you're familiar with Qt, like the way the interface works looks a little bit familiar, probably. Okay, so now it's very slowly playing through the animation, but you see now how I have, it's going through the first part where we have the rotation and the isosurface for half of it, and then the opacity is gonna slowly fade out from 1 to 0.
No.
So at this point, while we're waiting for everyone to play with it a little bit, you can just try adding other things and playing with that as well. So what else do we have that was interesting?
Strange faces.
A what?
Actually looks pretty cool.
Oh, the stream tracer. Yeah, let me add one of those. So we'll add the stream tracer.
So back on the pipeline browser, you add a stream tracer?
Yeah, right now I'm letting everyone do whatever they want. So if you want to just
Yeah, I'm good doing whatever I want.
okay, just get a hang of the animation panel. If you have any questions, let me know. And then after that, we're gonna look at how to do a rotation in Python and get information in Python. Okay, so I'm gonna add the stream tracer. Wow. Surface streamlines. Okay.
How long does it normally take to set up a VNC or to get a VNC connection on Stampede because they're queue?
It depends on the load.
But if
Yeah.
they've sent, I have an individual who said that they tried to set up a VNC connection on Stampede, and it just kind of locked up on them. So.
Yeah, I don't know what let's look at the queue.
Coloring.
Oops, I'm not logged in.
Cool.
So on Stampede specifically.
We added some.
Did you make it fatter?
Yeah, it doesn't look like the machine's too slammed. Was there an error message, or was it just taking a long
He
time?
just said he got as far as logging in, but then the screen just froze. I should probably just ask him if he's using Chrome.
Well, was he able to submit the job and it was running, or? or
It doesn't really specify. It's just an email that came in.
oh, I was on something non-Maverick. I tried to set up VNC on Stampede and got as far as logging in.
It's pretty much so, I mean, that can be a number of different things.
This still be it. It's colored.
We should ask.
Maybe if you can ask,
Steps to reproduce.
yeah, because he tried to set up, I'm not sure if he got as far as logging into the machine or the VNC session. And then I don't know, why does he say if this is ever fixed, I can access the archive version, and this is just trying to access the viz.training, the /training.
I think he just wants to look at the video, I'm sure he did
I know
that,
that.
like, process it, I think he's walking his way through it.
Okay, I didn't know why did he say if this is ever fixed, I can access the archive version.
Oh, okay. Oh, this. Right vectors came.
What did you add to the stream tracer animation? Just out of curiosity. I did something but it doesn't look cool, so I'm gonna try something else.
The skill mode is off.
Say that again.
The skill mode is off.
Okay.
And for this, if your mouse is on top of it, it's good.
If you unclick contour maybe,
Mhm.
those, because it looks like the contour is overriding it, if you unclicked it and then did the string tracer, would that be better? Would that look better? Like you have.
Oh, it could. I mean, I just meant the, there's a bunch of options here. I was just wondering which one she tried that looked good. This one looks okay, but. Let's see. Does anybody have any questions about the animation panel here? For VNC? How'd you get your color map imported?
Oh, this is in Fairview. I have some comments on it.
Oh,
I
okay.
can't even see straight. So.
Okay, so if there's no questions, I'm gonna move on to the scripting part. Is that cool with everybody here and remote people?
Give us 1 minute.
1 minute, okay.
Oh, I'm a happy woman.
What happened?
Where were you? You have no idea. I had a intern all summer last summer to make this happen. I'm telling you.
Do you want to use the animation?
I was trying, now mind you, it's a huge data set. I couldn't get the data amplification going, and I needed a high res. It's slow enough space so that it wasn't jerking all over.
Oh, okay. Yeah, it might not be the same way on where I think everything changes once you have big data and running in parallel, but I'm pleased you're pleased.
Please.
Yeah, it looks great. I guess since we have a small enough group, yesterday after you left, I mentioned we started editing color maps, and then I told everybody about you. So if anyone looks over her shoulder, I would like to look over Francesca's shoulder and just see the color maps.
And there's actually, I have a set of color maps that people can import. It's on the LAML. It's data science at LAML.gov, and then you can download them.
Okay, maybe I'll bring it up here so our remote presenters. So yesterday, I had mentioned that Francesca, who's an artist, has really impressive visualizations that she created using customized color maps. And she just, I'm not sure if everyone can hear her, but she mentioned they're available for use. What was this? Data science?
Data science.
Data science.
LAML. The LA. .gov, I believe. You want me, I should find it and then just give you guys.
Okay.
Look at that. Let me find, it might be under tools, I'm not really sure.
All right. Oh, is the movie that you guys made for the SE linked here? Yeah, that's great looking.
Yeah.
So here's an example of work that Francesca did using one of her customized color maps.
Best visit at
That won the best viz at SC. So I'll just play it while she's finding the link.
Oh, wow. Congrats.
Oh, this is the ocean one that we were talking
Yeah, it's the one that Greg and Francesca. I don't know why you're taking this class, Francesca. You won best viz at SC.
I haven't taught myself. I've learned so much. I mean, it's like, I beat my head against the wall. You know what? Why don't you just tell them that we'll post the link?
Okay, sure.
I have one, so I never have to do those.
All right, so.
I'll drop them a note and ask them.
Okay, so we'll post the link and Jason will send it out to you, but wait, let me open something really quick just so I can review how to do that. So as I mentioned yesterday, you can edit the color maps by selecting it in the properties panel. So if we scroll down under display and then we hit edit, then you see this panel, and then there's an import button where you can import a color map. So it's an XML file, and that's what we'll send to you. We'll send you the link that has different customized color maps. Let me go back to the slides really quick. Okay, so one really nice thing, I'm going to go ahead and start with the scripting section. Is that good? Cool with you, Francesca? Okay. One really nice thing about using ParaView is it has a trace function that will output whatever Python is being used for whatever command you execute. So if you have it in mind that you want to create a Python script to recreate a viz and you're not sure where to start, or even if you aren't familiar with Python, you can use the start trace feature to get familiar with what ParaView is doing. And between that and referencing a user guide, a Python reference manual, you can get a pretty good start to creating a reproducible script. And again, the reason why, let me hit play really quick. The reasons why this is useful is if you want to prepare a large render job, ParaView could take a long time for data to load into the GUI. Sometimes with big data, it's less stable. So you might find everything works beautifully when you have your tiny data set on your laptop, but then when you're on Stampede and trying to load in a really large data set, it might not even load at all. You need a large memory node, which might take some time. You have to wait. So it's best to prepare your visualization as a Python script and then submit your render job to a queue where it can take the hours that it needs to render. Also, VNC sessions, they're only 4 hours long. If you might have a render job that could take a day. It's really large. You can have a large movie. So you want to prepare a Python script and submit that to one of the supercomputers. Another reason for Python is automation and reproducible views. If you are creating some kind of, if you're trying to do something like create a scientifically meaningful sequence of images, and you want to make sure that you do things like use the exact same color map, the exact same camera, so you have 10 views that look the same. It's really hard to do that through the GUI because you're moving the mouse around with your hand. It's going to be slightly different. If you add that in a Python script, it's very easy to have the same visualization represented with a different data set. Say you can just vary the data set and then have the same image 10 times or 100 times or whatever you need. And then I've already mentioned this part, but it's often easier and more direct way to interact with the GUI. You can see what's going on. You know, you see something, you can see functions in the Python that says opacity, enter the value.
Libraries that you can pull the scripts from?
Well, Do you mean like from pair view libraries?
Oh, so
or-
I thought I missed something at the very beginning where you said there were some scripts that you could work off of instead of.
Yeah, well, there's the trace function
Okay.
basically will let you see the Python for whatever it is you're doing, which is what we're gonna see now. So it's a good way to learn, because whatever you do, you can just do start trace and it's gonna spit out the Python. So even for you, I mean, if you wanted to do something, you could spit it out and then ask Greg to optimize it for you a little bit, but.
I can change the capacity.
But yeah, so it's good as a learning tool. And then
Yeah.
also, so here's the Python documentation. The same thing if you do help, pair view simple, or help whatever you want within the Python interface, you can also get the documentation, but it's a little easier to search the web page rather than scroll around the tiny Python window. Okay, so let's go ahead and do something really simple. So I'm gonna start over. So edit, delete all, or just start a new session. I'm gonna go back to peer view. So we have, if you quickly want to restore your state from scratch, you can use this disconnect from server, and it'll delete everything and kind of refresh peer view. I often use that if peer view seems to be having issues and they want to restart it. Now this has the same effect as restarting it. So now the first thing we want to do is go to Tools and Start Trace. And then I'm going to say fully map everything just so we can see what's going on, and then show incremental trace. That means it'll start spitting it out as I go, which is useful for learning. Sometimes if I already know what I'm doing, I don't want to have the window popping up every time. I just kind of want to record the script and then save it. So I don't always choose that just because it gets annoying. But if you're learning, it's really, really nice to see step by step what's happening. So we'll go ahead and put all properties, and just so we can see what's going on. Again, like if you just want to capture a script that you want to reproduce, that wouldn't be necessary to record all the properties, but we'll do that. Okay, so now we hit OK, and it should record everything. So we're going to go to File, Open, and then we'll just use one of the, we'll use the disk out again and hit OK. And then we can see what peer view has done. Like, so now you know everything that needs to be done, that peer view needs to do to read in the data file. Opens up the reader, all the information that it has internally. I'm going to add all the variables, hit apply. Okay, and then I'm going to add one contour again. Select a variable, contour by. Do the same thing that we've been doing, temperature. 400. And then, wait, where's the view? Just looking for the apply, then coloring, color by pressure. Okay, the window seems to be hidden. Here we go. Usually every time you do anything, it kind of pops up right in front. Okay, so if we look a little further down, we can see that it has a comment line, properties modified on disk out. We loaded the variables. It got the active render view. Show data in view. So it's very verbose because I selected to show all the properties. Color information, contour display. Okay. So now let's go ahead and save out a screenshot. I'm just gonna call it test 1. And then move the camera a little bit. So we want to see how we can reproduce camera motion with Python. So we'll just do that and then save out another screenshot. We'll call that test 2. Okay, and then if we scroll down to the bottom, we can see what happens when we did those rotations. The camera view moved, and we can see it saved out a screenshot. The camera moved again, and we saved out another screenshot.
Those comments are nice.
Yeah, it is really nice. And also similarly, if we want to change something with, let's say if we want to change the contour to a different isosurface value, so let's just pick 500. And then hit apply. You know, it's a different isosurface. And we scroll down and we can see it just has a different contour, and then it rescaled the transfer function. So already we can see, I mean, if you have any knowledge of Python or any programming language, you can see how you could just replace that value with a variable and then have a for loop and then have it write out screenshot. So it's pretty simple to go from an example script to customizing it to whatever you need. And if you wanted to play with things and try it out, you could also, there's an internal Python shell, so you can try, you can also type in commands directly if you wanted to, or you could run the script from here. And then, as I mentioned, if you want to get help directly in the Python module, you can do help, say peerreview.simple, to get help on whatever it is you want. So if you have a question, you want to find more documentation about something that you see, that you've learned about, you don't know what all the options are, you can always do that as well. So now let's see how we can save out our script and modify it a little bit. Let's go back to the other window. So if you save, you should have an option to file save as, or save. And so you can just save it wherever you want. test.py. Call it whatever you want. Just, let me go back to the PowerPoint really quick. So I've logged this in the script as well. So we've created a contour, we've captured the script. And this is what I just pointed out to everybody. You know, you see something like this where you have the camera positions, save out a screenshot, change the camera position. So as we just have seen with the animation panel, you could achieve the same effect by having keyframes and animating it. But if you wanted to do this or something similar with the isosurface sweep or change any parameters, you could do the same thing. For camera motion, it's actually easier to do things like rotate and pan rather than using the camera up, camera position, camera clipping range to change things around. They have, the camera object has properties with the azimuth and I can't remember dolly. So for panning, you know, it's easier to just vary the rotation and the dolly position. So that's something that you can find out more about in the Python manual. So if you just find the area in your script where you have this camera view representation and then instead replace it with, you know, any fashion of incrementally changing the azimuth and the dolly and then save out an image in a for loop, you know, you can save out a bunch of images really quickly and then create a movie from that. So that's what we're gonna do. So this, at this point in time, it's a little different where your PV Python is going to be located. If you don't have it in your path, if you're using one of our machines, Stampede or Maverick, once you module load pair view, it sets the paths correctly for you. So if you type PV Python, it'll know where PV Python is. But for people that are running it on their laptops, whether it be Windows or PC, you know, often when you run things from the command line, and unless you set it up yourself, you know, it's not in your path. So an easy way to do that for Mac, if you don't have it in your path, just go to where it's installed. So in my case, I have an applications, peer review app, contents bin, PV Python. So I can just type that. And then if we look at the peer review sample, so we can see I loaded the data, at the active data source, viewport size, and then I've copied and pasted that little snippet that I just showed you where I have a frame count and then I just have a for loop that's gonna increment the camera azimuth position and then write out a frame that's gonna be called new cam and then appended by a number. That way I can make a movie.
And that's on your PowerPoint?
It's on the PowerPoint, yeah. Okay, so let's just see what happens. So to execute that, I need to use PV Python and then the name, review sample.py, and then it's gonna save out all the images. And then how many, does anybody know about FFmpeg or if they used FFmpeg? It's a application for making movies. But it's really nice when you wanna make a quick movie from a sequence of frames like this, and it's available on all of our systems. So oftentimes if you've done something like this and you just, it's for debugging purposes, you wanna look at your data or you wanna see if you're seeing the right thing, the command for FFmpeg. So if you're on our systems, you would say module load FFmpeg. And then you open up the PowerPoint again. So, and in our example, oops, let me play. In our example, if you name things the same way I did, it would just be FFmpeg-I, and then you specify the name and then the name of your movie file. So it's really simple, and it's going to be highly compressed, and FFmpeg has a million different options. If you want things to look really good, you can play with them all day long to use different compression and this and that. But if you just want a quick movie of some frames that you just generated, it doesn't get much easier. So you can get a quick idea, like, does it look right? Especially if you've done something programmatically, you know, do a quick check just to see if your data's looking good. And so you can use FFmpeg on our machine. All right, I can't remember if I installed it on my laptop or not, but let me try. FFmpeg, yeah, I guess I didn't install it recently. I thought I did before this demo because I remember having this happen last time, or maybe it's only on the machine. I don't think so, because I would have put it in my path. But anyway, let me just open. We can take a look at what it looks like. Let me just sort of by name. So one thing about FFmpeg, if you do go this route, it knows what to do in the case of sequential frames. So if one of your frames is labeled, if it's not sequential, then it will just die and say like it couldn't find the next file. So it assumes, the reason the command is so simple is it's assuming some things. So I didn't seem to have, I have a version that I made before of the movie we can look at. So there it is, rotating. Very exciting. Okay, so that's just a quick intro to how to use Python and access the trace function to learn all the Python that you need, really, or at least to get you started. Are there any questions? Yeah.
So if you so I was sent Python script with the data file.
Mm-hmm. Yeah.
It's like, so can you show us how to import?
Sure. Well, you could just go to Tools, Python shell, and so you could run it from here. There's a button called Run Script, and then you could try.
Oh, okay, just pull it out of my there. Okay.
Yeah, and it should. I could look at the Python file for you, but it should in the Python file specify the data that it's loading,
Yes.
I assume. So then that should be all you have to do. Your other option, you could run it the way that we did, which was to use PV-Python and then the name of the Python script.
Okay.
So it depends on if you want to interact with it in the GUI or not. Or I don't know what the script
So if I want
does,
to
but
interact with it in the GUI, do I use my terminal window or don't?
no, you would, because this doesn't give
Right.
you a GUI. It's kind of like bypassing the GUI, which is favorable in some cases. But if you actually do want to use the GUI, then you could run script and then it'll
Right.
open up and
Okay.
whatever the endpoint was of the script that they gave you will be the endpoint here.
Okay.
So
Perfect. Thank you.
let me see if there's anything else in the peer review slides. Quick demo. Yeah, oh, and then I really liked this tutorial, or these tutorials here. Just wanted to bring them up. If you want to learn more, I just wanted to put that up there. A lot of them are for older versions, but most things are similar enough that you can follow. You can follow them. All right, so I think since it's already almost noon, we'll go ahead and break for lunch until 1 and start up again with what's on our schedule at 1.
Well, we were gonna do visit, so if you want to do visit.
Well, what's on our schedule for 1?
Let me see.
I feel like because visit is so similar to peer review, I'd rather have peer review comprehensively covered and just do visit with what time is left over.
After lunch, Greg A is gonna do his parallel viz.
Okay, maybe we'll just stick with that then, and then just skip visit unless anyone in the audience has a major complaint.
Did you guys, are you okay as far as, did you need any additional help or? He's nice up this spot. Okay. He's left.
Okay, so then to end the call,
Yeah,
just go to Google Hangouts.
There you go. Go ahead and stop sharing, or you could just hit their little red, the
Hang up.
Yeah, that's fine.
All right, bye everybody. See you at 1.
And you are now the presenter. So you can go ahead and share.
Okay, and sharing is done.
On the left, just to the left of Google.
Oh, this guy?
And then you hit share on the bottom right.
Actually, I can do that one.
Do we have? Oh, I didn't know.
It didn't work? Really?
Nope, now it did. It did.
That's what you're seeing?
Yep, that's what I'm seeing.
Oh, okay.
So,
I'm seeing, you should see that, not that.
so what? Did you share the application or the screen?
Oh, I see. Yeah. So I need to go back to here
You're already on,
and then screen share.
and then the entire screen.
I didn't know that yet.
And then hit. There we go. That's good.
It is?
Yep, that's good.
That's cool.
Yeah. That's our infinite display there.
All right.
And then just pull up your PowerPoint. Hit hide on that. All right, that's good.
Now you have that.
Yes.
Means I can probably do this. So I need to set up power. So now you have the right thing.
So you have a swap display option. That's what you just hit.
It is, yes. So we either get the right thing here or the right thing there.
We had it.
Somehow it was working, right? I get it. Let's see. Oops, that almost worked.
Maybe it's not liking the fact that you have multiple desktops.
You think?
Well, yesterday it worked, but did you? And so now we're back to the.
Oh, it's probably the wrong resolution, right? No, that wouldn't
No,
make
that
sense because
was
it's on HDMI. Yeah, I have it on 2 screens, so I need the easy fix is to get it to only use 1 screen, right?
So go to slideshow at the top. Let's see. If you start, let's see what. You're not sharing now. Go ahead and
And now you're seeing.
now go ahead and share. You're not sharing it now. We lost the share. So
Right. So that means I need to go to.
just hit paste.
Entire screen, right? Okay, share.
And is the PowerPoint on this window? Can you bring the
Making part. The choosing part, you go back to that.
say something?
We may want to try the one that.
Let's do this. Let's
All right.
drag. So it's PowerPoint on desktop 1, Chrome. This is all on the same desktop. That's what I was thinking is that the.
So we have this guy. So you're saying use this one?
No, that's fine.
No, the one when you select your screen share,
Use this one?
yeah.
All right, let's try that one.
Okay, but that doesn't give.
And now you've got that, fine. Now if I go to this, I get that.
And, just a second. Mine one's easy.
So the problem is that's not on any of the screens involved.
No, this is what I'm.
What are you thinking?
I was thinking about taking it off.
But I've been knocked off now.
No, you're still on the call.
I am? Right?
But it's still showing the PowerPoint. The actual PowerPoint app itself, it's not showing them.
I don't think I'm still on, personally.
So, on Contour.
So let me go ahead and put you back to present. And now go ahead and hit share.
And so it changes the
Entire
rest.
screen.
You want to?
And then hit share. Go
Go
ahead
into the
and
rescale. Color map.
hide that and then bring up the.
Yeah, okay.
So we scan this one.
Yeah. The one that-
There we go.
Just a second.
Well, now we're back to,
And we'll go back to where we were before.
and you're getting this screen, so I think she might be right. I'm going to go back to the Hangout.
No, actually, that might.
Yes, technical problem.
So this
And
one's.
I'm going to go to screen share, and I'm going to try this one. And now we're there, and we all agree on that. How about that? Now we do this.
Yeah, it's special, so it should be different.
Yeah, well, we just have.
Well,
what is there 6 choice there?
Both of them use this.
what's that?
There's 6 choice there where you can pick which one to share.
You can pick
Oh,
application,
maybe
you can
not.
pick up the actual desktop itself, and then there's a couple other menu options.
So that's the,
But it's still,
and that's, this one is just the scale.
Yeah,
That's
okay.
can you restart PowerPoint?
Yeah. So pressure,
Yeah.
the information, and see what's going on.
Yeah. And you can scale the color map.
Yeah, I find that if I do that,
Oh, well, you know, another thought is, hang on, I've got it. I know what to do this.
Right, yeah. But I mean, that's what I mean, you can set the.
So if I go here and I do,
See, it doesn't recognize it, but the restaurant systems, the
can you send a note out on the chat saying we have technical problems, we're getting to get back as quick as we can? All right, so I'm going to kill PowerPoint and start this all over. So now we're here. I am on. I am going to, PowerPoint is not up. Yeah. Now, yesterday I did entire screen, I'm sure of that. I don't remember that happening, but hey. Hide.
go down below and see if the document. And now we have exactly what's on your screen.
I think it's because it's exactly what.
Now we have-
Here we go, ready?
I got it. It's good. It's good. We're good.
All right.
So it's just, we just had to restart PowerPoint. So we're going to do
Okay.
it. Okay.
If you would apologize.
But it's.
Okay, am I awake?
You're awake.
Okay. Excuse me. All right, I'm back. I'm still Greg Abram. I am going to talk here a little bit about parallel visualization and what the issues are with parallel visualization and why we have parallel viz servers here at TACC. I understand there's some people who would like to move on to sort of a laboratory format as soon as possible. So I'll sort of blast through this and then call for questions, and then we can have an open session after that. Okay, so parallel visualization at TACC. Why do we want to do visualization in parallel? Well, let's think about all the visualization problems that are out there in the real world. At the bottom part of the pyramid are small problems. These are things that are worked on every day in people's offices. There's PowerView running on your laptop will run just fine, and there's no need to do anything fancy whatsoever. Things get a little more complicated as data sets get bigger. There are a class of problems sort of in the medium, which are more costly to move over wide area networks, and where doing the visualization itself requires a lot of memory, a fast CPU and GPU, and it's really kind of outside of the capabilities of a laptop and more in the range of a office server kind of thing. At the high end, when data really starts to get big, data really is impractical to move over the WAN. I mean, if we're talking about terabytes of data, it takes an arbitrarily long time to move terabytes of data around. You just basically don't want to do that. And visualization itself is going to require more than one processor to have, more than one node to have enough memory to hold the data and enough CPU and GPU power to do the visualization. At the very top of the pyramid, the very top of the pyramid, we get data sets that are so large, and this doesn't happen a lot, but it's what makes life interesting for us in supercomputing centers like TACC. The data gets to be so large that it really can't even be moved off the system where it's being rendered, where it's being generated. So you can imagine there being a simulation that's running on our big Stampede system here, where just to download a time slice of that data out of the general purpose memory of Stampede and onto secondary storage is going to take a long time. I mean, it can take 15, 20 minutes, it can take hours. It can take long enough that writing it off is really impractical to do. And these really, really big data sets anyway, the visualization itself is as big a problem as the simulation. And the visualization really requires resources that are on the same scale as the system that was doing the computation in the first place. So if we look at the systems that you need to do these, like I said earlier, for these medium and small problems, you can really handle them either on your laptop or on the sort of standard server that any organization can acquire easily to do visualization. When the problems become really, really big, oops, I went the wrong way. When the problems become big, you end up having to move your data to a customized system for doing visualization using parallel systems like we have here at TACC. Here, moving the data is expensive, and so that's why we have systems at TACC that are really closely coupled to the big simulation systems, so that moving that data between a simulation system and a visualization system is as cheap as possible. And at the very, very largest problems, we don't ever want to move the data at all. Instead, we move the visualization process into the same system that's doing the simulation, so it all happens without the actual data ever being written off to disk at all. We call that doing visualization in situ, or in place, and that is a great solution if you kind of know what you want to show in the data, and if you really don't have the resources to write the data and save it offline. So, parallel systems. What do they actually look like? Well, typically, what you do with a parallel system is you sit in your desk, on your desktop somewhere, and you connect to a big system across the network. We have two big systems here that people do visualization on. The big one is Stampede, the small one's Maverick. But basically, they're just boxes on the other end of a network that you want to have do the work for you. Now, if you look a little closer at these parallel systems, these are distributed memory parallel systems. So the way you can think about it is as essentially a set of pretty powerful workstation class nodes sitting in a rack, or actually in this case, lots of racks, and connected to each other using a really high-speed network. Now, there's nothing really fancy about that network compared to the good old-fashioned internet, except it's an enormous amount faster. But it uses all the same TCP or InfiniBand technologies that are completely analogous to what's happening on the internet. Also in that box is going to be a parallel access file system that is accessible to all the nodes. So it's basically one big file system that any node can read from. So how does this all work to actually do work? Well, typically they work by a technique called message passing. One node tells another one, I'm sending you some bytes, here they are. And the other one says, okay, thank you, I've got those bytes, and now I can work on them. So it's a point-to-point scheme which we refer to as message passing, where messages contain data or requests that the application needs to have happen somewhere else. Like I said, this network is a lot faster than a standard network, but at the same time, it's a lot slower than just accessing a node's own memory. So you really can't look at this message passing as being like a larger memory system. It really has to look like individual messages that are being sent containing data. So here's the scenario. Node 1 tells node 12, here's some bytes, and node 12's happy. So now, if you look inside those nodes there in blue, what you really see is something that looks like this, where each one of those nodes, and this is true of your laptops as well, each one of those nodes contains a bunch of what we refer to as computation cores, which are what used to be referred to as CPUs, but are now cores. And they are inside one chip, and they share a chunk of memory. They share cache that accelerates accessing that memory. But basically, so basically what you have then is the system memory, which is the normal memory of the node, and a bunch of cores that are able to see that memory simultaneously at the same time. So typically, if there's a memory location, they can communicate by one of the cores setting a memory location and letting another core read that memory location. And it necessitates a process called synchronization. It's a little expensive, but basically these guys can talk by leaving stuff in memory and just going in and working on whatever part of memory they're assigned to deal with. You can also do message passing between these guys by putting messages in the system memory and having the other guy pick them up. Anyway, so the point I want to make in this is there are really two scenarios. Oops, well, looks like I'm going on to something else. There are two scenarios whereby these parallel systems communicate. One is by having a bunch of CPUs, a bunch of cores that are able to access one memory. And the other is where a bunch of nodes actually share the task by sending each other messages telling them what to do. Now, each one of these nodes can also have an accelerator in them. And typically, well, actually, in all of our systems, pretty much all of our systems, we do have accelerators. Accelerators are little specialized co-processors that live inside the nodes, and they have their own memory, and the accelerators are able to take parts of an algorithm and run those parts of the algorithm really, really fast. And the way these work is you have a block of data that's sitting in system memory that has to be processed. It gets moved over to the accelerator memory and processed on the accelerator, resulting in a block of results in the accelerator memory that then have to be moved back to system memory. So an example of an accelerator memory, accelerator system is a GPU. We put GPUs in these nodes, And we can use them both for doing the rendering that they were originally designed to do, but also for doing what we call GPU computing. GPUs are really, really, really good at doing certain types of calculations really fast. And so it's worth copying the data into the accelerator memory, working on the accelerator and bringing it back. That said, we also have, on Stampede, we have special accelerators called Intel Xeon Phis, which are kind of like having just a ton more cores in one box. So where a ton is 62, I think. And so it's essentially sort of having a node inside a node, where the accelerator has only a relatively small amount of memory, but a ton of cores that are able to work simultaneously. So these, in fact, become what we call hybrid parallel systems. They're parallel from the point of view of having a bunch of nodes that are able to communicate and share the process of working on data sets. And they are also parallel in the sense that each node is what we call shared memory parallel. So there's two, well, that are shared memory parallel. And it's also parallel in the sense that some of them may have accelerators, and those accelerators themselves are parallel tasks. So, now you know everything there is to know about parallel computers. The question is, why would we ever want to do this? This is only making things very, very complicated. And the answer is could be because we need more CPU. And looking at that again, the flashing guides there are because by using multiple nodes and multiple cores and multiple accelerators, we bring more processing power to bear on the job. We basically have more people helping with the task. We also increase the total amount of memory that's available. So we have a much larger amount of fast access memory that scales with the number of nodes that we apply. But we also increase the bandwidth to and from the file system. And I want to make it very clear, this is important. Basically, all of those nodes are able to read from the file system in parallel and at the same time. So if you have a huge data set that's sitting out there on the parallel file system, and you need to load it into your system memory, if you have only one node, it's only got one path to that parallel access system, and it will take you a certain amount of time to read it in. But if you have multiple nodes that are all trying to hit that file system up to a certain point, they can do it in parallel. And the I/O time will scale down with the number of nodes that you have working on it. And the dirty secret of parallel visualization is that's the big win. The big win is using parallel systems to maximize the throughput of data out of the file system and into the visualization process. So what systems do we have here at TACC for doing Viz? The one that is dedicated to Viz is called Maverick. It is 132 Ivy Bridge nodes, each with 20 cores. Each one has 256 gigabytes of memory, a pretty high-end GPU. It used to be a really top-end GPU, but Maverick's now a couple years old. It has a very high-speed interconnect, and it's specifically designed to be able to do high-performance visualization. We also have Stampede, which is our big server. It has 6,400 general-purpose nodes. Maverick had 132. This has 6,400, so it's a lot bigger. Each node has 16 cores, so not quite as parallel in terms of processing power. And they also don't have nearly as much memory, but they do have these Xeon Phi coprocessors. Now there are 16 special processors there that have a terabyte of memory each. And those have two GPUs on them. There are also 128 dedicated Viz nodes, GPU Viz nodes, that are the same as the general purpose compute nodes, except they also have a sort of medium level GPU available for doing both GPU computing and for visualization. These are organized thusly. We have one gigantic file system out there called Stockyard that is accessible from pretty much all of our big systems here. Maverick and Stampede both have access. They can both read files directly from the Stockyard file system. But as this slide tries to show you here, the access paths through from Maverick and Stampede to the stockyard file system are relatively narrow, where relative is a lot faster than your laptop's ever going to do. But if you have hundreds of nodes hitting it at once, you're gonna saturate the bandwidth there. Now, Stampede also has a special file system called Scratch, which is local to Stampede and which has even faster access. So Scratch has very, very high speed bandwidth to and from Stampede nodes, but it's not accessible from Maverick. So the beauty of this system is, if you don't need to share that data off of Stampede, you can use this super high speed file system. But otherwise, you use the stockyard file system, you can do your computation on Stampede, leave the data right there in stockyard, and load the data into Maverick afterwards for visualization. So now, when we're running these things in parallel, what is actually happening? Well, we use these things remotely. So what is actually going to happen is we end up using SSH, or the secure shell, to start a process on the front end node of the supercomputer. There we S-batch a job. S-batch is the tool that you use, the software tool that you use to start parallel jobs that run on any of these nodes, any of these systems. The job of S-batch is to allocate a bunch of nodes and start a shell file that runs on one of them. And the role of that shell file typically is to start a process that runs in parallel on all the nodes. Now, so that's the model. You have a bunch of these nodes inside Maverick that are doing the compute and doing the I/O and doing the work. But now the question becomes, what does this look like to the Stampede, to the PowerView or Visit user? The good news is they basically look exactly the same. If you were confused by them before, you will still be confused, but you won't be any more confused. Okay, so it's a good thing. They are both based. Was there a session on Visit? Have these guys seen anything about Visit? Okay, forget I said anything about Visit.
I mentioned it a little bit as I was going through.
Okay, well, Visit is analogous to PowerView. So when I say Visit and PowerView, they're for all intents and purposes the same. The world of general purpose visualization on open source tools is divided into people who are fans of one and fans of the other. It's like half of New York likes the Mets and half of New York likes the Yankees. But I'm a diehard PowerView guy, so we're strictly Yankees around here. Okay, so they use a client-server architecture. And that's actually what you see when you run these things in parallel, even if you're running it on parallel on your own laptop. It's a client-server architecture. It allows multiple processes to run on different nodes. You run a client that runs on the desktop, and you run server processes on all the nodes, and the result of putting them all together is a parallel process. Now, as it turns out, neither PowerView nor Visit are threaded, so you can't use all the cores on your laptop to do visualization, naively with PowerView. Even on our big systems here, if you just run PowerView the standard way that you've been running it so far, it will only run serially and will only have access to one of the cores on the node, which leaves a lot of processing power unused. Instead, we run a parallel process where we have multiple servers that are running in parallel, even on a single node, even within your laptop. To take advantage of all the cores on your laptop, you will run it parallel on your laptop using however many processes you have as cores. And you divide up the resources of the node amongst the processes that are going to be running. So what does it actually look like when we're running this from afar? From the local system, we allocate a set of nodes. We run the parallel visualization server processes on those nodes. However many there are, we run more than one on each node so as to take advantage of all the cores on those nodes. We start a client we make it look like the client is running on the local system. We wire it all together. I'm sorry, this is the typical client server interface. You run one of those nodes, and then I now see where I was going with this. One of those processor nodes is Magic. It's the root node, so to speak. And it is able to communicate with a client process that runs remotely directly. So that allows you to connect the remote client to one node of the parallel process. And that node, that magic yellow process of the parallel processes orchestrates communication with the client and all the necessary communication. And your visualization, lo and behold, shows up there on the GUI, even though the computation and the rendering and everything is happening over on the big system. Of course, that's the easy way to do it, and that's not the way we do it. And there are a lot of reasons for that, which I'm not sure I'm going to go into until I see the next slide. Yes, okay. And you saw this, I think, earlier. I think you had a session on remote viz, right? That talks about how we use VNC. And so how we, in fact, have an additional front end, additional process. The client is actually running over here, and we use VNC to make it available there. So anyway, that's the point I'm trying to make here, is that whether or not this is the way to do it, and whether or not we're using VNC to do it, this is the way that it works, right? Like you have a user interface that's running on your local system, and it's communicating to a process, to a parallel process that's running on the big server. So once we know that, the question becomes, how do all these nodes, these processes over here, actually cooperate to do a visualization task? And this is the typical way that most visualization applications take advantage of parallel systems. This is, in fact, the way that most high-performance computation is done. We break up the data set into parts. We assign each one of those parts to a parallel process that works on those parts at the same time, and then we put the results together at the end, right? Now, as it turns out, in order to get the correct answer at the boundaries between these partitions, they have to overlap a little bit. And so we copy what we call ghost zones onto the edge of these partitions. So this partition over here is responsible for all of these red blocks of the data, but it also has copies of the edges of the blue, yellow, and green partitions. This guy is responsible for the green guys, but it also has copies of the edges of its neighbors. That way, if we try to get an answer for this point right here, which is actually the same as this point right here, it has information on both sides of the boundary to get the right answer. So the long and the short here is, we divide up the data, we share information at the boundary, and the result is data sets that can be handled pretty much in parallel. And an awful lot of algorithms work out really nicely that way. Isosurfaces being one of them. We can compute the isosurfaces independently in each partition, and you get the right answer if you have the ghost zones. So for example, here is an isosurface, and the answer here is going to be exactly the same as the answer there, because the entire environment of that point is available on both of these nodes. So you get the right answer. Each one of these is responsible for about the same amount of data, and so naively, they're going to be doing about the same amount of work. Of course, nothing is ever perfect, and you can get a bad distribution of the data, of the workload, and bad stuff can happen. Like in this case, if all the interesting stuff is happening on one of these nodes, inside one of these particular partitions, the processor that's responsible for that partition is going to be doing the vast bulk of the work. And so you get a bad distribution of the overall workload. Neither ParaView nor Visit nor any of these visualization applications that I know of do any kind of load balancing, dynamic load balancing, to alleviate this problem. So if this is the case you have, and you're going to end up seeing all of the work, or the vast majority of the work done on one node, and it's not really, the parallel computation is not really going to help you much. So that's a pitfall, that's a problem that is easy to fall into. And the way that we think about it is by dividing up the data set into lots and lots of partitions, the likelihood of any one of those partitions dominating the link length is relatively low. There are other applications, though, that don't work real well in this scenario, streamlines being one of them. Remember that a streamline is what you get if you drop a soap bubble in the airflow coming outside of an air vent. You trace it through the room. Let's imagine now the computation of a streamline where we've seeded that initial point right here. It's going to run for a little while in that partition, and that partition, the processor responsible for that partition is going to be nice and busy while the other three are idle. Then that streamline is going to have to get moved over to the neighbor. The neighbor is going to be busy for a while, and then the other guys are idle. And so at no time here is more than one processor ever working at the same time. So here, the parallel compute has not helped you at all. No processor is no more than one processor is ever working at a time. Now that said, if the data set is so large that it won't fit onto one node, then this brings the ability to have all of the data in physical memory simultaneously. And that way, the algorithm doesn't have to be swapping data to a disk to bring in parts of the data in order to fight. Imagine for a moment that we only had one node here, and we only had enough memory for one partition at a time. When this streamline exited the volume here, the processor would have to flush out this data set and load this data set. And that would take a long time. And then the minute that it's finished in this partition, it would have to flush that partition and read this one back in again. So by having it working in parallel, we're able to aggregate the physical memory of all of those nodes, and it will be much faster than if you were doing it on one node that did not have sufficient memory. That said, the other way of making this work better is to have lots and lots of streamlines, all of which can be computed simultaneously. And again, depend on the fact that they're going to be distributed over lots of partitions to make sure that lots of processors are all working at the same time. So that's basically what we talk about when we talk about data parallel visualization systems. We then have the problem, after all those have happened, that we end up with geometry, stuff to render, that exists out on all the different nodes of the parallel system. So this node up here has the parts of the streamline that coincided with its part of the memory, part of the data set. It has its part of the contour line that coincided with its part of the data set. But all of the data that we have to actually render a picture of doesn't reside on a single node anywhere. So we have to figure out some means of rendering all of that data and producing a single image that's going to come out at the end. And there are basically two ways of going about it. I'm not sure there's a slide here. One way is to gather all of this data onto one node and then just render it in one place. The other way is to render it all locally, wherever it actually lives, and then do an image compositing to put the final image back together. And both of those are supported in Visit and ParaView, and they'll do it based on various heuristics about how the workload is going to be best performed. So now I spoke earlier about I/O being the dirty little secret of parallel visualization, being the big win of using parallel systems. Now, there is a caveat to that, and that is that not all data sets can be handled in parallel. It can be loaded in parallel. Basically, each one of the processors needs to have a dense piece of the data locally. It can't have a tetrahedra here and a tetrahedra there and a tetrahedra here and have all the intermediate tetrahedras on other nodes. It needs to have all the tetrahedra that fill a block of space on each node. Now, if those tetrahedra are just spread out at random in a file. That entire file has to be read and partitioned to split the data up among the available nodes. So typically, in both visit and parallel and paraview, what's going to happen is that entire data set is going to get read in on one node. That node will be responsible for chopping up the data set and distributing pieces of it to each one of the servers, to each one of the other server nodes. So the downside of that is only one node is doing all the I/O, and you've lost the biggest advantage you have of using a parallel system. So instead of using a data soup format, where the data is just in one unstructured trash bag full of data, we use structured data formats. And there are quite a few of these that are specialized for doing parallel I/O. We can basically take a partitioned data set from the simulation stage and write them out into separate blocks in the file system that can be read in parallel. So in other words, the simulation had to have this data partitioned in order for it to run. Rather than putting all of that data into one big trash bag on the disk, we can preserve that partitioning and reuse it in the visualization process if we use a structured data format in order to represent it out on the disk. And there are a bunch of these things. Both ParaView and Visit have their own sort of specialized one, but there are a lot of them. And the point I would like to leave you with here is if you have partitioned data to begin with, you should keep it partitioned as long as possible so that you can take advantage of parallel I/O in order to accelerate the I/O problem. So like I said, ParaView has its own native formats. Visit has the silo formats. There are other formats that are out there for specialized purposes, but there are lots of parallel formats. Now, how does visualization actually happen in the supercomputing world? We do it, the typical way of doing it is by a process we call post-processing. In a post-processing world, we first run a simulation to create a large amount of data, and then we store that data on a file system, and we later load it off of that file system into a visualization host where we do the visualization. So it's pretty much a two-step process where we have a simulation that runs to completion, followed by a visualization that then starts up and runs to completion. And the beauty, as I said earlier, of our stockyard file system here is that we can share that file system. That file system is accessible from anybody, so it doesn't matter that we do the visualization and the simulation on different supercomputers. So the point of all this is, when the data gets big enough to start having to deal with it at places like TACC, I/O becomes the biggest issue. And in order to do visualization of these really, really big data sets, you basically want to make sure that you're not moving any data that you don't absolutely have to move, because moving data is where the expense arises. So basically, in a post-processing simulation, you have the expense of writing the data out to an external system. You have to write out a whole lot of time steps in most cases. And subsequently, you have to read it back in and visualize it after the simulation is completed. But I also want to underline that there is this alternative of incorporating the visualization directly in the simulation to begin with. So rather than writing out this raw data, which can be arbitrarily large, we can render out pictures of the data during the simulation, and there's no data movement at all other than is necessary to save out these images. So in co-processing, we have two different sets of processes that are running on the same supercomputer, and we're able to use the communication system of the supercomputer to move the data from one set of nodes to the other really, really fast without ever having it to write to horribly slow disks. In the in situ case, we actually install the visualization process inside the simulation, so the data can actually be picked up directly from where the simulation is working on it, and there's no data movement whatsoever. Now, both of those are not perfect. You pretty much sort of have to have an idea of what you want to see before you do it, because what you're going to be generating is, the images you're going to be generating are going to be generated from data that's going to disappear, and you can't run back the clock. So it's not like this is an exploratory technique, but it is a very effective way of showing off what your simulation is intended to show, if you know what your simulation is intended to show. It's bleeding edge. We're interested in it here, and we work with it. Interesting to mention, there's a system called Cinema at the Los Alamos National Lab, which is sort of a in-between process here that we're getting to have a fair amount of experience here with. The long and the short of this is, if you have a big visualization problem you need help with, please let us know. We would be interested in helping you with your problems. So in summary, on the parallel visualization front, parallel visualization is really only partly about upping the compute power that's available. It's also very heavily about getting sufficient memory and I/O to bring to bear on the problem in front of you. And I/O is a huge issue. Planning how to write your data for parallel access and putting it where it can be accessed quickly is critical to getting a big visualization done in anything like reasonable amounts of time. And my group and nearby groups are here to help you with these problems as they arise. It's sort of what we find fun. So, thanks for coming. Those are me and Anne. You'll be able to find these slides online when I give them to Jason. And that is it for parallel rendering, parallel visualization. So, I'm going to call for questions. Anybody online with questions? Anybody in the room with questions? Those two are completely ignoring us, so they probably don't have any questions. Okay, we're waiting for questions from the field before we dismiss this section and go on to anything.
No, we were just going to have the last hours individual help and questions and answers.
Okay.
I hope if anybody has any difficult questions, like so we can ask right now. Well, we have them. Especially with peer reviews for the expert.
He's actually, because you're the one that's been presenting.
We presented, but you have to be.
Those that can, do. Those that can't, teach.
He insults me all the time.
Yeah.
Just can't do that.
And those that can't, they're just sit there.
Okay, any questions arriving from the field? Okay, then we're good. So let's take a bio break, and then if anybody has some interesting problems to deal with out there in the real world, we will see what we can do to help you. If not, if you have problems that come up later on, please feel free to let us know. Okay, thanks for coming.
All right, thanks. I can IM you if anyone has a question. Any questions?
Did you really have a problem you wanted me to help with? Because I do have real work to do.
So I'm looking to get the H3D. I don't know if it's, so I don't know that I have your last email. I've got
That's
this
fine,
one you
yeah.
sent
I'll be
yesterday.
happy to shoot him an email. In fact,
Go ahead and send me today.
You sent one today.
your email,
But
CC.
That's exactly what I was looking into. It's not anything that doesn't refer to anything that you can deal with now.
I believe that's.
Well, how about I just send it to you?
So,
And
can you just explain to me what these files are?
What files?
So it's the H3D data,
just use my email.
and I want to,
That's fine.
already state file?
Yeah, just say, I'd like to introduce Jason.
I didn't even look at it. Did you look at it? Did you run it?
That's kind of my role.
It's a Python.
Not if it's a state file. It's not.
Well, but
What is?
Well, you can run the state file on ParaView, and you can run the Python script using PV
but
Python.
I need to do that in parallel.
I have no idea.
Probably
Ask who?
has a point
Ask
of
him?
contact.
And? Something like that.
Well, I don't know, so
Basically, is that
I've gotten into this before, and for some reason now, tabs that I'm using are probably, so I'll close
You're
it.
just getting flustered.